Welcome to Spring LIB.
Hi, today we're going to be working on a problem that addresses how accurate the small amplitude approximation really is for a simple pendulum. So the first thing we're going to do is look at the different periods for both small amplitude and approximation, and for the small amplitude correction. So we're going to look at the simple pendulum period. The one with the simple approximation is just going to be 2 pi times the root of the length divided by the gravitational constant. Really pretty simple. We can plug all that stuff in, and that ends up being about 2.84 seconds. Next, we're going to look at the more accurate formula, which is going to be the period is going to be equal to 2 pi times the square root of L over G times 1 plus 1/4 of sine squared of theta over 2 plus 9 over 4 times 16 times the sine to the fourth of theta over 2. And this is the correction out to 3 orders for this period. We can see before we even start that we've got sines that are squared into the fourth, and the argument of sine is always going to be less than 1. So these terms are going to get pretty small. When we plug in all the numbers, and we can realize that this is just the simple period. So we can say this is going to be equal to the simple period times all this stuff, remembering to convert from 30 degrees into radians. And then what you're going to end up with is that this is going to be the simple period times 1.017, which is going to be about 2.89. So we can see that the periods really aren't that different. In fact, the difference is only 1.7%. I hope this helps explain something about the small amplitude approximation for a pendulum. Thank you very much.